Hello, everyone. We are doing the Hydrosphere continuation. However, we are going to quickly review over the water cycle Hydrosphere slides. So remember that 90% of the hydrosphere is in ocean. That means how much water we have. So 90% of the water here on Earth is ocean, and only 3% is going to be fresh water. Please remember the water cycle is constantly moving. Okay, it never stops. This is an unending circulation of Earth's water supply. Okay, and that is called the water cycle. So, again, remember running water starts as precipitation and either infiltrates the surface to flow underground or becomes runoff and creates streams and rivers. Please remember that. So, today, our main focus is hydrosphere, surface water. So, we're coming from the standard EEN 232A illustrate the water cycle to explain the connection between groundwater and surface water, detailing how groundwater moves through the lithosphere. So we have to emphasize the process of evaporation infiltration again, and we already did about the water cycle. So just as a quick review, the water cycle is powered by the sun. The sun gives energy. And so what happens is we have evaporation. And once it evaporates, it goes into what we call, of course, precipitation. And if it comes down, it can come in different forms: rain, sleet, snow. Um, we have transpiration that comes from the plants, right? And so then condensation, that is going to be when it releases back into dew-like droplets. And then we have perlication, as we just mentioned earlier. So perlication, these are the words that you need to know. There's some that's missing here, but make sure you have an idea in the of what the water cycle is. But surface water. Runoff is excessive water that does not permeate into the land and flows over the surface instead. As you see here, it's coming through the little field and it's coming off the hill downward. Runoff may reach a stream, river, or lake, may evaporate or accumulate and eventually seep into the ground. So sometimes runoff can either just seep into the ground. A lot of times, as you see, it just comes off and it makes little streams. Um, Runoff is a great thing to also look at, like your ditches. When the water runs down from your house and it runs into the ditch, and then the ditch takes it to wherever the water source may be, that is really an example of a runoff, but that's a man made runoff. Now, there's factors that affect runoff. So we have vegetation. It reduces runoff by allowing more water to enter the ground. Precipitation is basically, of course, gentle rainfall causes less runoff than a torrential downpour. So this right here is if we just had a shower and it's like sprinkling outside, that's not going to give us runoff like it is when we had like Hurricane Matthew and all that rain just came and roads was flooded and stuff. So those things, there's different factors that would actually affect soil composition. High runoff is soil consists of silt, clay, or shale. Low runoff is soil consists of gravel or sand. You ain't gonna get a lot of gravel and sand just to move, but if you got like this little dirt and stuff, you see it all the time. You drive your car and it's wet. You leave these big old marks in your yard. If you have a slope of a ground, the steeper the slope, the higher runoff. Shallow slope is low runoff. So if you're almost equal, you're not going to go nowhere. A lot of times, the water can sit right there in your front yard. But some people who live on the hill, that water runs down. So what about streams? Well, a stream is a channel with a permanent water flow. Tributaries are streams that flow into other streams, increasing the size of the stream. So this is just a connection channel. A large stream is called a river. People are like, no, a river is just a river. No, it's really just a large stream. That means it's basically uh, a lot of streams that came into one that eventually is going to go to the ocean. And so when it's a lot of tributaries make up a stream, or we call it a river system. Smaller ones is known as creeks and brooks. And a lot of times you find creeks in the back of your house, or around your neighborhood, where you have all these trees, and all of a sudden you see the just a little bit of water that runs in between the trees, because those are creeks. Those creeks go to a river, and then those rivers go to the ocean. So surface water for rivers. So what is really the river doing? Well, the flow of the river or the stream is actually due to gravity. So gravity is what pushes the river or the stream. Discharge is the speed at which it flows. So this is the volume rate of the water, or how much water is passing by. If you ever looked at a river, or even go down 295 and you can see the Cape Fear River, of where how fast it pools and the currents pool, this right here is everything happens because of gravity. So here is a formula. Discharge equals width times depth times velocity. We may have one problem on how to solve this, but we're not going to focus a lot of math inside of this classroom. Moving water carves a path. So stream banks are the ground bordering the stream on each side. A stream channel forms a moving water erodes a narrow paths into rocks, creating sediment. So the formation of stream valleys. Well, as you see here on the slide, you notice that it states that as a young stream actively erodes its path through the sediment of rock, a V-shaped channel develops. Okay. Then if you go to the next one, as it matures, it goes into a U-shaped, because it begins to slow down and meander. So an old stream has a gentle slope causing meandering and wide flood plain with natural levees. So a stream erodes until its base level, which is the elevation at which it enters another stream, a body of water. So until it kind of hits the elevation and the base level, it'll keep on going. So stream load, we have three ways: solution, suspension, and bed load. Solution, suspension, bed load. So as you see here, we have the bed load, solution, and suspended here inside the images. So meandering streams, as we mentioned earlier, which is caused by older or mature stream. This is where the slope decreases as it gets near the base level. Sometimes the water begins to erode the sides of the channel in such a way that the overall path of the stream begins to bend or wind. So basically, the meander is the bending or the curve in the stream channel caused by the moving water. You don't really just see a lot of streams and stuff that are straight. Everything has some type of curves and everything. This is caused because of meanders. So the meandering streams outside of the curve, heavy erosion occurs on the outside. So on the outside, okay, fast flowing water, because a lot of times, even if you go to the water park and you're sitting there, it's nothing like when you can go straight down, but when you hit them curves and stuff, you're sliding up the ramp, and you're sliding across, and the speeds and stuff are just tremendous. So the thing is, you have a lot of friction. That's why they make the sides of the walls a little bit bigger on the water parks, because they don't want you to fly out because of the speed. But also, if you hit that corner, you gonna get a scraper or something as well. So that's what happens, because that's where you see the fastest current comes off of those bends, and this also gives a lot of area for heavy erosion. So inside the curve occurs basically when you're on the inside. This right here is where the less water is, so the friction is not as strong. It's just when you get to that outside, it ain't nothing like when you going down that slide and you hit that outside, your elbows and everything be tore up. So, still talking about meandering streams, it's common for a stream to cut off a meander, once again, follow a straight path. So, not saying you can't have straight, but eventually you're going to have some curves. So, you're going to have some meanders that take place. A cutoff meander is also known as an oxbow lake, which is eventually it dries up. Um, and at the mouth of the stream, the gradient begins flat and the channel becomes wide. So deposition of sediment. So we already know that when we do this, it does cause erosion, but when we have a lot of deposition of sediments, we get to make a lot of other things as well, such as different rocks. In dry regions, a stream's gradient may suddenly decrease because the stream to drop its sediment at the base of a slope is as a fan-shaped deposit called alluvial fan. Okay, so what you really need to know from this slide, you need to know the definition of alluvial fan. Keyword delta. Now, for those who are into sororities, you understand there's a sorority called Delta. And when the women do their line, they put their hands together and they make a triangle. That is Delta. So, Delta is a triangular deposition, usually consisting of silt and clay particles that forms where a stream enters a large body of water. So, this again, triangular deposit, and it goes into a large body of water. Surface water and groundwater. So before we get ready to come to a close for our notes for today, we have to know the difference of surface water and groundwater, but they kind of work together. One of our next slides we're going to do from here is going to actually go back into the ocean, and then we're going to go into the currents, and then the climate, and then the human impact. We will mention some today. Groundwater and surface water have reciprocal relationship regarding regularly feeding each other. Most streams get about half their volume from groundwater. So as you see here, we have the surface water, but you see the groundwater flow lines here. They get about half of their volume from it because, again, as you see, it can come from anywhere, but the underground water, it stays there. So basically, that volume that you see inside the surface water, such as streams and rivers, is actually coming from groundwater. So estuary is the area in which one or more rivers enter into an ocean, creating a brackish water. Wetland is an area for at least part of the year which the soil is completely saturated. So basically, the area surrounding estuaries is typically going to be a wetland. So of course, we live over here in this area, so we do have predominantly wetlands. Now, the farther we get to the coast, as you see, the more we have. But right here, actually, there's some deep water habitats near Hope County. Okay, so that let us know that we're near some water somewhere, as well as you see all the wetlands. And again, wetlands is that you can go outside and it just your ground can hold water. Because somewhere there's a underground or the groundwater supply, and then somewhere near you there's going to be a river or a creek, because that water has to eventually go somewhere so it can go back to the ocean. And you notice we stay here where my mouse is pointing at, so we get a good amount of wetlands here. So now, why do we need to preserve the estuaries? Well, don't some of y'all like fish? We need to do that. Don't y'all like going to the beach? Well, we need to save it. Y'all like animals? Well, let's go save them, okay? We got to keep it populated. We got to keep it clean. And this is also, honestly, this is where a lot of animals and stuff just basically, they populate and reproduce. So this is normal for some of us. You can actually walk down the street or get ready to go to a pond, and you can see some of this. Wetlands naturally filter pollutants, can withstand excessive amount of runoff because it can just sit there. It does prevent flooding, so that's when, if you ever went to some of the farms and you see the water just sitting on top. Plants assist in stabilize the shoreline, so that's why those plants are there, like cattails and stuff. And of course, it gives life to animals. So a bog versus a fan. What you have to know is what a bog is and what a fen is. So bogs are characterized by poor soil and high peat content. So what does this look like? Most of our grass in our front yard, yes, poor soil, high peat. Fens have less peat and plant life than a bog. And here, this is where you start walking into the woods and you start seeing some of this. Most of our yards look like this, okay? We got bogs. Going into your forest has more of your fens. Swamp and marsh. So here's a swamp. Now, swamps, you actually can just drive down the roads here in Hope County and you're going to see all of this. You be like, they ain't putting a little rail up or anything. Now you go in the swamp if you want to, but it supports woody and planted trees. Now marshes is what is something typical that we see, especially after it rains. A marsh is that wetland that supports a variety of reeds and grasses. So the water kind of just sits there. It's a marshy area. All right, so watershed. Y'all watch the video if you did your work for it today. But a watershed or a drainage basin is the land area that contributes water to a stream. A divide is the imaginary line that separates the drainage basin from one stream to another. So yes, there is a place that the water has to go. It can pretty much holds your water. So just because we have to talk about NC drainage basin, as you see here, we have in the Raleigh area, we have this is the we're in the lumber area, which obviously, of course, but we also some people live more the Cape Fear region. So that's our river basins, and this is honestly where you get most of your water supply from. Okay, um, so that's kind of where it's at. So this is the Neuse River and everything, but we get our water as into from the lumber and Cape Fear. So watershed drainage basin. So as you see here, we're there's a lot. There's a big one here. This is one of the biggest ones, the watershed of the Mississippi. Um, that is something that you just have to pretty much. You just more or less something to know. But we are at the end of North Carolina is what gets it. So it's going to be around like our mountain areas where it runs off into this place. Threats to our water supply. Well, pollution. Look at this factory. Look at that water. Like, that's not good. I ain't got to be drinking that and swimming in that. So we have to see pollution is a big threat. Pollution from general areas like farming. So you see how this water is not as clean, but you see here animals. They have the suburban development, city streets and stuff. So it's just coming from dirt, from poop, from cities, from trash. This is what the non point.